Happy Tuesday, everybody. Welcome in. Coach Anderson here. Hopefully everybody is doing all right today. What's going on, Zoom user? Jennifer, welcome in. We're going to have another follow-up, like we said, to distance rate time with some even more brand new questions. And it's going to be a nice, fun one for us because we're going to learn exactly how to handle distance rate and time. So hopefully you guys are excited. Welcome in, Caleb, Giancarlo, Kirsty, welcome in. Shell, welcome in, and Eliza. Welcome in, my party people. Give me 1 second. Actually, I have to go ahead and forward the Zoom link over to a student who actually just got the program. So 1 second. Perfect. All right, there we go. And then I believe that there's perfect. All right, there we are. So we're going to get started pretty soon, everybody. Give it about 90 seconds and we'll go ahead and start this party. Hopefully everybody is doing well today. Welcome in, my party people. Oh, what's up? You got a 71? Hybrid. You know what we got to do. Everybody, since we have the time before class starts, I'm going to let you unmute yourselves. Give Hybrid congratulations there. Go ahead.
Congratulations, man. You already know. Yeah.
Congratulations.
I love it. I love it. Let's go. So 71, that's not easy. That's not easy at all. So Hybrid, congratulations. Let us know how you did it, which, how long you studied for, because we always want to be conversing with each other seriously about, hey, how did it work for you in terms of, how you studied? Is there something that you did that I can take for myself? That way I can go ahead and, take strategies. So go ahead and let us know if we have the opportunity, but I'm really proud of you. Congrats on the 71 and welcome into those who are just joining us. So thankfully we are able to get this class today recorded. So hopefully by the end of the week, we're going to get this up live on the website and continue the trend of giving you every single recording. So welcome in, everybody. Hopefully everybody here is doing well. Let me go ahead here and check this. Perfect. All right. So welcome in, my party people. Today, again, it's a follow-up of yesterday's class. So before we get started, who here was here in yesterday's class? Yes or no? All right. Cool. So it looks like the vast majority of us were here yesterday, and it's totally okay if some of us weren't. It's absolutely okay. So here's the thing. Today's class, or yesterday's class, we really took a good amount of time, a really rich amount of time to go over that distance rate time formula. And, you guys tell me, for those of you that were here in yesterday's class, you tell me, is it true that when you're setting up your formula, it definitely matters in terms of, hey, does the information line up? Is the information consistent? Yeah, absolutely true. So just like with any, and I mean any other topic in terms of arithmetic reasoning, whenever you're setting up your formula, whenever you're setting up your equation or your solution or whatever it might be, consistency is key. Understanding what you're plugging in is more important than the actual numbers itself. So we're going to review that formula. We're going to also review how to identify each piece in a word problem, starting with that question that we left off on yesterday evening. And then we're going to handle situations with multiple pieces, just like we did yesterday, but with some more questions today. So with that said, my party people, just like with yesterday's class, remember to work in the program in order. Everyone here should be in the program. So make sure that you start off with the math basics, then going through the arithmetic reasoning and math knowledge, and then from there, that ASVAB AFQT practice test course. So we're getting ready to make an update to the AFQT practice test course. We're getting ready to add perhaps up to 10 new arithmetic reasoning tests. And then we're going to work more on math knowledge to give you a more robust experience in there too. So get excited, my party people. But remember that if at any point in today's class you're having any issues calculating with decimals or unit conversions or whatever it may be, those calculations that you feel like are fundamental, well, that's all right here. I'm going to zoom in case you can't see it because we all know it gets blurry sometimes. Again, it says math basics. That's the course. you want to go to. Cool. So all jokes aside, again, working the program in order and everything else is going to take care of itself. So just like yesterday in every single class, try every single problem out. And remember that discomfort that we're going to feel in today's class and at any time that we're studying, it's natural. Your mind's going to try to distract you and keep you safe. But remember that you're going through this because you want to grow, get a higher score, get the job you want, and then the rest is history. So with that said, my party people, go ahead, type in hashtag ASVAB, and let's have ourselves a great day. Appreciate you guys coming in on a Tuesday. Let's make it happen. Right on, my party people. So let's go ahead and let's get things started. So just like in yesterday's class, we're going to start off by just reviewing that distance equals rate times time formula. So what are some things from yesterday's class, my party people, that you feel you're a little more confident in when it comes to the formula? What are some things that you're more confident in today than you were yesterday? And I definitely don't want to see in the chat box the word everything. I want to be specific. Let's go ahead and pinpoint some things. Like, for example, oh, there we go. When Jennifer says, hey, distance can mean anything. It can be an amount, it can be pages, it can be miles. Again, yeah, anything that you're trying to accomplish, for sure. That's one big takeaway, because if you're dealing with a problem that is talking about a water tank and gallons per minute and things like that, yeah, you definitely need to understand that that's a rate. So segueing that, anything that you're trying to accomplish is a distance. What do we learn about rates? What's something that we knew or learned yesterday about rates? Identifying them, working with them. What did we learn? Well, the word per is a keyword, a big keyword. Absolutely. If we're going to talk about rates over here in blue, absolutely. And don't worry if you haven't seen these notes yet. I'm going to zoom out and give you a chance to take a screenshot. But when we're looking at per or rate, excuse me, the word per really gives it away. So like pages per minute, pounds per month, miles per hour, dollars per hour. When you're blending two units together, saying, hey, this many pages per 1 minute, this many pounds for each month, that's a rate, that's a speed. That's how quickly you're accomplishing something. So my party people, just to get a confirmation there in the chat box, yes or no, does that make sense? The word per really gives away the rate being shown. Right on, right on. And when it comes to making sure that the units match up, is anybody here mad about that last problem yesterday that we were able to review in terms of that unit conversion? Anybody here still mad? Yeah, no worries. I got you. We're going to make sure to, we're going to get some retribution today for sure. Still super mad. Hey, right on. Oh, hybrid. Thank you for replying there. So, hey, coach, I studied for 2 months. I followed the program, arithmetic reasoning, geometry, and using the formulas helped me out a lot. Plus, I used the word knowledge apps that we recommended. Excellent. So, hybrid, if you have a chance, I would love to see your story shared up, on our side of things. So if you would take a moment here, look at this link that I just privately messaged you. Go ahead and drop your experience in there, because we want to make sure that anybody who's coming in the future to raise their scores can get the confidence that they need, that this is something that works for them. So I would really appreciate that. Congratulations on passing. And I hope you're staying through the rest of class. That way you can continue to learn. But getting right back to it, my Porter people, let's go ahead and take a chance here to screenshot this if you haven't had the chance to. And yeah, thank you. So let's go ahead here and have a little bit of not a pop quiz, but just like a refresher here and talk about things before we get into the practice problems straight away. My party people, if we have two rates and I say that these objects are moving, we have two objects, they each have their own rate and they're moving in the same direction. What are we typically going to do with those rates? Ooh, okay, you guys are quick. Yeah, we're going to be subtracting those rates. If the rates are moving in opposite directions, what do we do? right. We are absolutely supposed to add those rates. And again, don't worry if you weren't here in yesterday's class. We're going to be going over this in detail to make sure that everybody can be on the same page. But I have to follow up on that though, because when we talk about combining rates, so if we see that we have, two objects and two rates for each, or one rate for each, and we see same direction or opposite direction, you have to be careful, my party people. You have to be very, very, very careful. Because, everybody, you can only add or subtract the rates if what? Who knows this one? This is a really good question here, and you would have had to really, really, really be locked in to every single detail I said yesterday to understand this one. Ooh, okay, there it is. So that was Jennifer and Jay getting it in. That is correct. If the objects are moving at the same exact time. That's the only way that you can combine the rates. If you have two objects moving at the same time, and if you have opposite directions, you add them, same direction, you subtract them. But they must be moving at the same time for you to be able to combine them, because the rate has to be going over the same time period. Everybody, does that make sense? When we choose to add or subtract rates, we need to make sure that those rates are being applied for the same time period. Cool. And again, even if you weren't here yesterday, don't worry. We're going to take it nice and slow once we get there. Don't worry at all. I got you. So with that, just some reminders, just like, with yesterday's class, make sure that you know that those units are matching up for sure. Always go to the question first, the question sentence. That way you can get the goal. Always make sure that you're looking at your goal and making sure that you set up your formula consistently, like over here. So like we said yesterday, if we're trying to find Bethany's time for her trip, then we need to use Bethany's distance and Bethany's rate. We can't use Andrew's rate or Brandon's rate. It's Bethany. If we're talking about Bethany in the formula, then everything else needs to be talking specifically about Bethany. That's the consistency that I mean, and that's what we're going to be reviewing over and over today. I got you. So, similarly, if you're looking for the time for the entire trip, then you're using the rate and the distance again for the entire trip. It's really important to note this, because today we're going to be going over questions that are going to ask you to find the rate while you were driving, and then the rate for the entirety of the trip. And that's going to really twist some people up, but it's going to be amazing to see how a minor shift in detail makes the difference that you need to get the problem right. And I know so many of you guys are going to make sure to get that done. So with that, who is ready to try some practice problems out? Right on, right on. Remember how this works, my party people. I'm going to give you 2 minutes and 35 seconds just about. On the ASVAB, you can expect 2 minutes and 26 seconds. But in today's class, you're going to be expecting 2 minutes and 35 seconds per question, just in case we have a little bit of delay with our internet connections. So remember to refrain from sharing those answers until the time is up. All right. So let's go ahead and get that timer up. Right over here. And then let me go ahead and set that timer. 2 minutes, 35 seconds. Excellent. My party people, remember, every decision you make, whether you get the problem right or wrong, every bit of effort that you give is going to push you in the right direction. So don't be afraid to give your best, because all we're going to do is get better. 3, 2, 1, let's go. All right. Looks like a lot of us did our homework and, we got an answer by ourselves. No worries at all. I love seeing that. So let's go ahead and review this first one here. But before we do, my party people, give me your confidence rating. Do you feel nervous? Do you feel confident? Where are we at? Go ahead. Nervous? Everybody should feel like a 10 out of 10, like you know that you got this. Aaron, 8 out of 10. When I know before you've given me a 4 out of 10. So there we go, Aaron. I like seeing that. Confident, 10, 8 out of 10. Okay, cool. So remember, everybody, the point that we're trying to get to is the point that we know that we're right well before I step in to review it with you. That's what true confidence is, because you have such a good fundamental understanding of what's going on. So let's go ahead and dominate this here. Step one, as always, what do we want? Always begin with what the question is asking you to find. So right here, how far apart in miles are the cars now? So when I hear this, everybody, how far apart are the cars now? What does it sound like we're looking for? When we say how far apart, does it sound like we're, looking for, okay, yeah, distance. Absolutely. That's what we're looking for. When you ask for how far something is or how far apart these two objects are, yeah, that's distance. That's absolutely distance. Now, because we're dealing with two objects, I've taught you guys, hey, let's think about the situation. When we have two objects and we want to know the distance between them, we have to really consider what each object is doing individually and in relation to each other. Here's what I mean by that. Let's take a nice little read. So right over here, two cars begin in the same place and travel in the same direction. Okay. Now, typically, everybody, as I taught you, what does that get you? What does that really signal to you in your brain when you see two cars begin in the same place and travel in the same direction? With your training, what goes on in your head? What light bulb goes on? What does that tell you to do? Hey, Tyler, I appreciate that. Thank you. Yeah, typically what we think automatically is, oh, we have two objects starting from the same place, same direction, subtract automatically, right? Subtract those rates. That's what you've been thinking. That's what you've been taught to think. But we have to understand, everybody. Remember what I said after the fact as that little fine print. The only way that we can ever add or subtract rates together is if those objects are what? What did we say? Well, yes, of course, for sure, Jennifer. We need those same units, but more importantly, yeah, they have to be moving at the same time. So if whether they're moving in opposite directions to add or same direction to subtract, they have to be moving over the same time period for us to manipulate the rates specifically. So let's take a look at how this problem is slightly different. So read along with me. The two cars still begin in the same place, same direction. So I can go ahead and say, hey, we have car A going in that direction. And then we have car B going in that direction, right? So that's what's happening. We're still going in the same direction. But when we see here, this first car travels at this speed over this amount of time, 5 hours. And then the other car travels at 62 miles an hour for 6 hours. So that's the biggest difference, a 5-hour period and a 6-hour period. So here, because they're not moving at the same time for the same period, we can't just say, yeah, 62 minus 55 and we're done. No, we can't. However, what we can do is still think about it like this. Because if car A goes this distance in the 5 hours that it drove, and car B went this distance in the 6 hours that it drove, we're still doing the same thing though. Instead of subtracting the rates, we would just have to default to subtracting the distances. Okay. We can't assume that we can't combine the rates by subtracting simply because it's not the same time period, but we can still just go ahead, find the distance for A, find the distance for B, subtract what they have here, and get the gap here. My party people, does that make sense? Instead of subtracting the rates, because we can't, instead we'll just subtract the distances. All that means is you just have to take a little more time. Calculate the distance for the first one, distance for the second one, and then just subtract. That's all it is. That's all it is. And so let's demonstrate that. So for anybody here who's a little unsure, I want to show this to you step by step. I got you. So I'll go ahead and move this over to the side. Excuse me there, got to get a better angle. There we go. Cool. So here we go. Car A. We see that car A, and I'll highlight car A. I'll use green here. So we see that the car A, its rate is 55 miles per hour, 5-hour period. So I'll write that down here. Rate 55 miles per hour. The time, it's going to be a 5-hour period, so 5 hours. Car B, we understand that car B, I'll use a different color here for car B. I'll use purple. So car B is traveling at a rate of 62 miles per hour over a 6-hour period. Great, sounds good. 62 miles per hour over a 6-hour period. And there we have it. And so now what we need to do is find the distance for the first car, find the distance for the second one, because since we know they're going in the same direction, all we need to do is subtract those distances to find the gap in between. So there it is. So here we go. Distance for A equals 55, rate times time. So 55 is the rate, the time is 5. Everybody, what's 55 times 5? Help me out. You know I'm bad at math. 275, I appreciate that. There we go. So 275 miles, that's how far car A has traveled. And when we take a look over at car B, just shifting over, making sure to show both still, we have the distance for car B being the rate times time, so 62 times 6. Everybody, 62 times 6, again, help me out. I'm bad at math. What's that going to be? 372. So the only surprise here, is simply that car B went further than car A, but it doesn't matter. We're still going to subtract. The only correction that I should make would be this. Now that I know how far they went, car A went 275, and then car B went 372. So it should be something like that instead. Do you guys see where I'm going with this? And there it is. So that's all it is. We're good. We are absolutely good, everybody. So again, this here is 275, or excuse me, 275, and then 372. And so we'll subtract to find the distances between them. So we'll do that right over here. 372 miles minus 275. You know, with some mental math, you'll understand that this is going to be 97. But we'll go ahead and do the work here. So we have to borrow here to 2 to make that 17, then drop that to make it 16, and that's 12. 12 minus 5 is 7. 16 minus 7 is 9, and then that's going to cancel. So we have a difference of 97 miles. So here to here, that's a gap of 97 miles. How are we feeling, my Porter people? And no worries if you're coming in late, Mike. We're doing the first problem today was the last problem that we left off on in yesterday's class. Hey, right on, Jennifer. Let's go. Let's go. I love seeing this, man, because I remember a time when every single one of y'all jumped into one of these classes for the first time and you guys were petrified. Like you were so afraid to make a mistake, so afraid of feeling like you're being judged, but you're not. We're just here to just get one day better, one day at a time, staying on our own lane, achieving our goals, and living life that we want to. That's it. So with that, everybody, are you ready to continue, not the punishment, but the fun here into the next one? Sounds good. That's what today is. Today is a practice class. And again, you'll know when you see even more brand new questions. Every single question here today, you've never seen in my website, at least before. Here we go. Next one, go. And looking at our final 4, 3, 2, and 1. Everybody go ahead, put those answers in as always. What do we have? What do we have? Go ahead. And again, put a question mark next to your answer if it's a guess. No shame at all. Put a question mark next to the answer if it is a guess. It's all good. Super confident on D. Okay. Okay. Y'all are almost telling me that y'all are good. Y'all don't need me. I'm kidding. Let's go ahead and check this out. We got this. So everybody, especially for those of us that are fresh here, for the first time, what do we always do? Every word problem, no matter what do we want to make a habit of? Every single time, the first thing we do is read the question. Again, not read the problem. That's not what I'm saying. I am not saying, hey, on a trip, Andrew drove. No. I am not going to open a dictionary unless I know what word I'm trying to define. Just like here, I'm not going to open up the whole problem. I'm not going to read the whole thing unless I know what I want out of it. So what you want out of it is always in the question sentence right here. What was the total distance traveled by Andrew? Right there. So that's it. That's what we want. And so, everybody, if we're talking about finding the total distance traveled by Andrew, it's possible that we could be talking about, Andrew doing separate parts of a trip, or it could be just one leg, who knows? But we're simply trying to find the distance that Andrew travels across whatever story we're telling right now. That's all it is. Whatever this story is, whatever it has to do with Andrew, we want to know the total distance that Andrew travels. So let's get that information. Let's make sense of it. Let's have some story time. So on a trip, Andrew drove 60 miles per hour for 8 hours. Something I like to do, everybody, is when I read over the numbers, I don't care about the numbers. I say on a trip, Andrew drove this fast, miles per hour, speed, rates, so this fast for this amount of time before taking a break for an hour. Then he drove this fast for this much time, and that's it. You guys see what I'm doing there? I'm not stressing about the numbers because I know what I'm supposed to do with the number, because it's a 60 or a 63 or whatever. The number doesn't affect anything. It only affects the actual calculation, but it doesn't change how I calculate. Never does. So read past the numbers. It's about miles per hour. It's about hours. It's about the break. It's about driving again for this fast, this long. That's what it's about. And if I want to show that in a diagram, it means that we have Andrew driving this far, then takes a break, and then Andrew drives again, and then we're done. And so here's how I'm going to write that and kind of diagram this. I'm going to use red to show that first leg of the trip. Andrew drove 60 miles per hour for 8 hours. So I'm going to say that to find this distance, to find that first distance here, it's going to be 60 miles per hour times 8 hours. Rate times time. The break, everybody, what's the distance on the break? How do we know how far we go when we take the break? Right, nothing, 0. That's it. That's it. You don't go anywhere. That means a distance of 0. And then lastly, over here in blue, we see that he drove 76 miles per hour for 4 more hours. So that's going to be a rate and a time of 76 and 4 respectively. So everybody, here's what we're doing. What we're doing is we have what we need to find the distance here because we have the rate and time. We know that the distance during the break is 0. And we know that the distance for that second leg is going to be found with the rate times time again. So all we have to do to find the total distance from here all the way to the end, we are going to find this distance here plus this distance here. Find those two, add them together, and we are done. My party people, does that make sense? Awesome. Now let's make this look easy. Let's have some fun because remember, the first most important thing to do in a problem is to set up your solution by making it make sense based on the story. Once you have it making sense and you're ready to calculate, then you worry about actually calculating. So here we go. First leg, that first distance, 60 times 8. 60 times 8, that's going to be 480. And then from there, moving forward in blue, the distance for that second leg, because again, we don't care about that break. We don't go anywhere, so it doesn't affect the distance. So here, 76 times 4, mental math, who has that? Yep, that's going to be 304. Quick mental math tip, quick mental math tip. 76 is 70 and 6. 70 times 4, 280. 6 times 4, that's 24. That's easy. So 280 plus 24, that is 304. Mental math, super easy, super quick. Math made easy. So with that, coming back out here, we know what we need to do now. We have our distances. Let's go ahead and add them together to get that total distance. So total distance equals the 480 right over here, plus the 304 right over here. And that's going to yield a final answer, total distance. That's going to be 784 miles. So Andrew had himself a nice little road trip. Sounds like he went from like Orlando to Savannah, but there you go. My party people, how are we feeling? Is that confidence really starting to show? Or are we feeling like, yo, we're getting there, but we really still need a ton more practice? Let's go. I'm telling y'all, man, step by step, one day at a time. One day at a time. As long as you take it nice and slow, it's gonna come to you. You're good. Right on. So let's go ahead and handle this next series of questions. Give me one moment while I just look at the background here. Let me see. Excellent. Excellent. So here's what I want to do, everybody. I want to experiment here real quick. Are you guys cool if we go ahead and do 3 questions back to back? 3 questions, specifically 3, because they're all very similar situations. So you'll have that advantage. You'll know that they're similar situations, but I'm asking potentially, who knows, different things, same things, who knows? It's going to be up to you to actually, sort through the words and understand what's going on. Yeah, all 3? Let's go. All right, let's make that money. Here we go. First problem coming up. Let's put that timer on the screen. And here we go, my party people. 3, 2, 1, number 1. Okay. Let's see how confident that is. But we have to wait until we finish all 3 back to back. So here we go. Again, short-term memory. How you did on this question does not affect your confidence with this next one. Let's go. Brand new question. 3, 2, 1. Let's go. Hey, no worries, Elia. We're going to be revealing all 3 answers after the third question. This is 2 out of 3. And after we go through the third, we'll review one by one. Right on. Okay, looks like we have pretty similar answers. Let's go ahead. Again, short-term memory, whether we feel like we got it right or got it wrong. Remember that when we're doing the test for real, the goal is to have that short-term memory. Okay, next question. Maybe I can do this one no matter how you felt about the last one. Third question. There you go. All right, my party people, looking at the final 2 seconds. 1, and that's 0. That is 0. Go ahead, put those answers in. Put a question mark next to your answer if it is a guess. Let's go, my math party people. We got this. Again, come on, exude that confidence, because remember, it's 3 separate questions. It is not 3 questions, all at once. It's one at a time. So I really want to help you practice your time management skills. And on top of that, being able to stay calm regardless of how the previous question may have gone for you. My party people, does that make sense? Sweet. Sounds good. So let's go ahead and get the party started. Let me get this timer out of the way. And here we go with question number 1. So starting with number 1 here, let's work through it. So first things first, what are we looking for? And so we got to read that question. That's right, Jennifer. On repeat. How many miles did Jeffrey drive after the break? Okay. So remember, if you see anything else in the question other than the who, what, when, where, how, which of the following, you want to understand that that is conditional information. So notice that this is not where the question starts. It's right here. If the trip was a total of 999 miles, then how many miles did Jeffrey drive after the break? So we have to take that into account. That is extra information, but that's something that is a fact for this problem. So here we go. How many miles? So we're looking for distance, but specifically, everybody, which distance are we looking for? The whole trip, part of the trip, specifically which part? What are we looking for? Right. We're looking for that distance after the break. That's right. We're looking for that distance after the break. So, sounds good. So if we kind of go through and, first we write this down, we'll say distance after, be specific, after the break. Okay, cool. We know that that's in miles, but once we know that, we start reading through and we start picking up on the story. On a trip, Jeffrey drove this fast for this long before taking a break for an hour. Then he drove, 7 more hours. Okay. So it sounds like there are 2 legs and we know the total. So we know leg 1. I'm going to highlight that in green right over there. And we know that that's going to be a rate of 80 miles per hour. That's a time of 4 hours. I'm not going to calculate yet. I'm just going to write down my information. Then we take that break. And then we have the second half. And all we know about the second half is that it was 7 hours. That's all we know. 7 hours of driving time. That is all we know. So how do we get the final answer? Well, what we know is that the entire trip was 999 miles. So we know what the entire trip is. And so just like we talked about yesterday, everybody, let me zoom in just a little bit here. Just like we talked about yesterday, is that if we want the distance from here to here, well, guess what? What we're going to have to do is take away that distance that we found from here to here. That is going to be this right here. That distance, if we take that away from here, all that's left is what we want from here all the way to here. But part of people, does that make sense? That if we have that total distance, that 999 miles, and we subtract that first distance right here, if we subtract that, then we will get what's left. Yeah, that's right, everybody. That's how we get there. That's the easy, intuitive way to think about it. But then applying that concept, applying the actual math, well, it's just a matter of knowing your formula and how to calculate and then subtract. So here we go. How do we find that first distance? That's, again, right here. That first distance is going to be 80 miles an hour times 4 hours. 80 times 4 gives us 320. So that's a total of 320 miles. So therefore, my final answer is going to be 999 minus 320. And that will be what? Subtract 300, so 699, then 679 miles. And there we are. And there we are. Final answer here is 679 miles. Now, did we need to use that 7 hours of driving, everybody? Yeah, nope. That was just extra information. And that's going to happen. That's going to happen. And here, did the break matter? No, because we know that the distance for the break was 0. The distance for the break was 0, so we didn't exactly have to use any of that. So we're set. We have our final answer. That's going to be 679. All right. Any questions before we move on to that next one, everybody? Any questions at all? All right, sounds good. Hopefully we're feeling pretty good and hopefully we're continuing to feel better. So next up, with the second one here, we see that, on a trip, Deborah drove. Everybody, what am I doing wrong? Oh, iPhone. I got you. Here you go. If you wouldn't mind, there's that link. I want to go ahead and shout out. I wish I knew your name, but your name is iPhone in the Zoom chat. So iPhone actually just scored a 60 on their ASVAB, letting me know, while we were doing a problem, they didn't want to disturb everybody. But I want to go ahead and take the opportunity right now to everybody give a congratulations over to iPhone. Don't know the name yet because you haven't let me know yet, but you did get a 60. Proud of you. You said it only took you 2 months of the program, and that's what's up. Every single time, man. I got to congratulate you every single time on that. Congrats on getting the score you wanted. Hopefully it was the score you wanted. And remember that if it wasn't, hey, consider giving it another shot. Because remember that it's so amazing to be able to wake up and do something that you love versus something that you feel like you're forced to do. So always strive for the best. Congratulations. I just dropped the link there. Oops. That's the link to the Zoom chat. I meant to give you the link to the review page. That way you can go ahead and, again, share your experience so other people just like you who want to succeed in the same way you do, they can keep that energy going all the way through the program to the score they want. Hey, right on. So with that, there you go. Yeah, now it's available to everybody. So with that, let's go ahead and get back into this one. We have this energy going. I love today's class, man. Here we go. First things first is, what was Deborah's average speed to the nearest mile per hour? But here's the caveat. It says while driving. While driving. So what does that mean? What does that mean? So remember, everybody, true or false? You have to be consistent when setting up your formulas. True or false? We have to be consistent when we're setting up our formulas. Yep, and that is true. We can't just throw numbers here and throw numbers there and hope for the best. That's not how this works. That is not how this works. It has to be methodical, and here's how we can be methodical. So we understand here that we're trying to find the speed, Deborah's speed, specifically while driving. Let me make sure I'm very clear about that. We're looking for the speed while driving, and that's going to be blank miles per hour. However, though, everybody, when we set up our formula to find this value, when we set up our formula, one thing we must make sure that we do is that we must make sure that when we say distance equals rate times time, we must make sure that we're talking about our driving distance, our rate while driving, and the time that we spent driving. That's the consistency that I'm talking about, everybody. That's the consistency. Does that make sense, everybody? We can only use the time that we spent driving to find the rate that we were driving at, and only use the distance that we drove. Hey, right on. So with that, let's go ahead and see what we can put in. So we see over here that, okay, Deborah drove 75 miles per hour for 7 hours, took a break, and then she drove again for some time. So what are we supposed to put? Everybody, do we know what the total driving time was? What's the total driving time? Because remember, we're looking for the rate. So let's look for everything around it. Do we know what the total driving time was? And if so, what is it? Yeah, the total driving time is 9 hours. Exactly. We see that we have 7 hours here. We have 2 more hours here. And we also have the 30 minutes. But the 30 minutes doesn't matter because that's not the time that you spent driving. That is a break. So it doesn't matter. It doesn't matter. Everybody, does that make sense? We can ignore the 30 minutes. Excellent. So we know that that's going to be a total, again, of 9 hours. So 9 hours of driving. Excellent. Now, everybody, the distance, we need to put in the entire distance that we drove. Because notice, we put the entire time that we spent driving. We need the entire distance that we drove. And so how do we do that? Well, that's going to be the distance for that first leg plus the distance for the second leg. So here we have to be pretty quick, snap our attention over and get some quick calculations done. We're going to check this out over here. And then we're going to check this next part right over here. Those two. So let me just highlight them both in purple. And there we go. So we'll do for the first distance, 75 miles per hour times 7. Everybody, what's that going to be? 75 times 7 is going to give us what? That's right, 525. There we go. And then for that second distance, we're going to go ahead and find 84 miles per hour multiplied by 2 more hours. So that's going to end up being 168 miles. There we go. So therefore, everybody, we're going to add these two together. We're going to add these two together. And that's going to give us 693. 693 is what I have. Confirm there in the chat box, everybody. Is that what we have when we add this all up? Again, I'm bad at math. Right on. So yeah, we have 693. So that is our total driving distance. We're looking for that rate for the entire drive, and we're multiplying that by 9 hours. So now what we do is we're going to just show this as a regular equation, and we're going to divide both sides by 9 to get the final answer. And there we go. So we're going to show this over here on the side. 9 going to 693. 9 goes into 69. That'll be 7 times, because 9 times 7 is 63. Brings that 6. Drop that 3. 9 goes into 63. 7 times. And there's our final answer. The rate for the entire trip, while driving only, is going to be 77 miles per hour. And there we go. There we go. Notice that because we only cared about the rate while we were driving, we ignored the brake. Sweet. So let me highlight that answer for you. That's going to be 77. That's going to be C. And now let's go ahead and move forward here to question number 3. Let's take a look at this one. This one's going to be slightly different. You know, we're talking about Deborah here, talking about Donna there, and it sounds almost the same. If you look at the words, these are essentially the same exact problem. Almost the same exact problem. The only difference is this. Over here, we're looking for Deborah's average speed while driving. Here, we're looking for Donna's average speed for the entire trip. That's the difference between the previous question and this one. That's the only difference. So, boom. And so, Perry, I saw that direct question just to answer that quick detour. Coming back over here, the way I knew how to divide is that when we try to get R by itself, well, we see that it's 9 times R. So to get R by itself, you do the opposite of multiplying, which is dividing. So that's what that was real quick, just to make sure I answer that question. Don't want to leave anybody hanging. I gotcha. But coming back over here, again, this question, very similar, but also very different. Do y'all see, verify that for me, do y'all see the difference here where it says we're looking for the speed for the entire trip? Cool. So this is the same question, except we have to take into account the break that we took for an hour. We have to take that into account. So here we go. Same deal as the previous question. We want to get the total distance. And that's going to be the rate times the total time. Again, we just have to be consistent. If we're talking about the entire trip, we need the entire distance, the entire time that we spent on that trip. That's how we're going to get the rate for the entire trip. And so with that, everybody, what's that total time going to be? Let's highlight that. We have 5 hours over here. We have the break for an hour. And then we have 6 more hours of driving. What's all that going to add up to? What is all that going to add up to? So 5 hours, a 1 hour break, and then 6 more hours of driving. Yeah, that's going to be 12. When we add all of that up, that's going to be 12 total hours. And that's going to be right there. That's 12 hours, not 11. Did anybody have 11 in their solution and is looking at this a little bit with some regret? Yeah, I got to make sure to keep y'all prepared, right? I got to make sure I keep y'all honest about the way that we do things, because we don't want to assume that the way that we did the last problem is the same way that we're going to do the next one. Can't assume that. So we have that total time. Let's find that total distance, just like we did before. We're going to find that first leg right here, 80 miles per hour for 5 hours. So my first distance is going to be 80 miles per hour multiplied by 5 hours, and that's going to be 400 miles. And yeah, so let me answer your question for sure. And someone else just answered it there, Jennifer. But the reason that we need to take into account the break in this problem versus the other one is because in the previous question, we only cared about the rate while we were driving. So we only cared about the time that we spent driving. But, and again, that's because you have to be consistent with the formula setup. But over here, it says, hey, what was done as average speed to the nearest mile per hour for the entire trip? So that's why in this situation, it's a little different. We have to take into account the entire time we spent on the trip. And that includes the break. That includes the break, because we took a break in the middle of that trip. That is inside of the trip. So we account that. So let me know if that makes a little more sense, guys. Jennifer, for you, perfect. Anybody else that was confused on that, let me know if that makes a little more sense for you. Cool. So let's go ahead and come back here and let's get that second distance. I'll go ahead and mark that over here in green. And I'll go ahead and do that over here. So that second distance, that's going to be 95 miles per hour multiplied by 6. Everybody, 95 times 6. What's that going to be? 570. That's what you got there. Yeah, that'll be 9 times 6, 540 plus 30. Yep, 570. So now that we have that total distance, what's that going to be, everybody? 400 plus 570. What's that going to be? There we go. 970 miles. And for anybody who's confused, I got you. At the end of the problem, I'm going to do a quick recap, because again, this one's definitely a little novel. It's going to feel a little confusing if we haven't seen it before. So we have a total of 970 miles. So I'm going to put that right there. 970 total miles equals my rate times 12 hours. And so essentially that's going to look like this. So now that we have 970 equals 12R, everybody, what do we have to do to solve this problem? And make sure to be specific. Tell me what I'm doing and where. That's right. Divide both sides by 12. Divide both sides by 12. That's right. So here we're going to divide both sides by 12, because remember, we're working backwards now to solve this equation, and we're good. Robbie, I got the 12 by adding up all the times. I had 5 hours in the first leg, the 1 hour break, and then this is the second leg here for 6 hours. We count the 1 hour break because we're trying to talk about the entire trip, and we took a break in and during the trip. So coming back over here, and again, I'm going to recap this once we're done. I got you, no problem. So now that we're here, we're going to go ahead and cancel that out. And then we're going to have R equals whatever that division is. So let's go ahead and figure that out right here on the side. 970, 12 goes into 97. That'll end up being what, everybody? 12 goes into 97, 8 times. That's right. So we subtract here and we're going to get 96. leaving us 1. And then from there, we drop the 0, and we ask ourselves, how many times does 12 go into 10? That is going to be 0. That is correct. And now at this point, it looks like we are going to need to go ahead and give ourselves a little wiggle room, because the problem says to the nearest mile per hour, and I see that, well, we only have one potential answer, because if we are at 80, it's possible that we might have to round up to 81, depending on what the decimal is going to be. But I see that there isn't even 80 as an option. It's simply going to be 81. And so we know that we're going to have to round up. I know the answer is C, but let me prove it to you. Let me show you here. Let's continue the division. So this is where we are. We brought this down, and now we have 100. Everyone, 12 goes into 100. How many times? Yep, that's going to be 8. So there it is, 80.8. We subtract 96 and we get 4. And you can continue if you want to, but you have enough. The 8 right there tells you that you're going to round up. That's going to tell you to round up. And so the rate is going to be 81, approximately 81 miles per hour. And there we go. We zoom on out and we'll highlight that. C, 81 is the answer. How do we feel, everybody? Do we feel like that's a little more manageable there? The only difference between the previous question and this one was that we had to take into account the time spent during the break. That's the only difference. And that it was just one change there. Instead of looking at only while driving, this one was the entire trip. Right on. So this is what I do. Whenever I create brand new questions for you guys to try, the one thing that I always focus on is making sure that you guys don't become dependent or reliant on patterns that you see. I want you to treat every question that you do as if it's a brand new one, and it requires your full attention without making assumptions based off of the previous ones you've seen. So I want to make sure that you guys stay on your toes. That's what this is all about. So again, for those of you that anybody that was confused, no worries. This is a tough one for sure. But the main difference between the previous one and this one is simply that we had to add in the break when we calculated that final rate. My party people, are we good to move forward to the next set of questions? Right on, right on. So here we go. This next set of questions, what we're going to do is we are going to go ahead and run 3 questions back to back. Now, one of these you might be a little familiar with. Maybe you were here yesterday and you saw it. But then with the other 2, like we just did with this situation, might seem like a similar situation, but you got to pay attention. Got to pay attention. And as a reminder, everybody, do the units have to be consistent in the formula? Yes or no? Oh, yes, they do. That's the only hint I'm going to give you, everybody. That's the only hint I'm going to give you. Here's your timer popping right back up. 3, 2, 1. Let's party. We're doing 3 back to back. All right, looking at our final 3, 2, and 1. You know, I can't tell you yet if you got it right or wrong. We have to go through the motions. So hopefully we're not grabbing drywall just yet. Let's go ahead and dive into the next one here. Again, regardless of how confident you were on this one, brand new question. Here we go. 3, 2, 1. Let's get it going. And looking at our final second here, and time. My party people, go ahead, put those answers in. Put those answers in. What do we have? Right on, right on. And just like we've been discussing, everybody, you know, we're not here to dwell on the past. We are here to move forward and give it our best. Nathaniel, I saw that you're having connection issues. Go ahead and come out and come back in if you'd like to, if you want to give that a shot. But here we go. Starting off with, or starting the last problem here. Final one here, 3, 2, 1. And don't worry, we'll still have time to do plenty more questions before class ends. This is just the final of this quick set of 3. And looking at our final 3, 2, and 1, put those answers in. Put a question mark next to your answer if it is a guess. Go ahead, put a question mark there if it is a guess. If it's not, go ahead and state your answer. You're good. You are good. All right, so my party people, what did you notice that you needed in terms of a skill to be able to get this done? You know, what skill do you feel like you really, really need to be able to get this done? Right, we need unit conversions. We gotta know how to convert units here. And so, has anybody here ever heard me talk about these fundamental skills as part of problems, and they're not the whole concept, right? You've heard me talk about that, like being able to handle decimals, being able to handle unit conversions, being able to solve equations. Those are skills that will help you solve a problem, but it's not the overall idea. It's just a detour that you have to take to get it done. So with that, let's go ahead here. Let me get the timer out of the way. And let's see if we could turn these moments of confusion into clarity. Here we go. So first things first, read the question, as always. So about how far to the nearest mile did Barbara drive? Okay, sounds good. How far did Barbara drive? Sounds good. And it says to the nearest mile. So, we'll take that into account for sure. But everybody, is it clear here for this first one? We are looking for the distance that Barbara drove. Good. Yeah, man, it's pretty straightforward, right? Pretty straightforward. That's what it says. How far? So that's distance to the nearest mile. They give you a distance unit. So yeah. So what else do they give us? Well, they give us a time, and then they give us a rate. So it almost feels like this would be super straightforward, super easy, because you have exactly what you need. However, although you are given a rate and you are given a time, it's not as simple as saying 67 miles per hour times 45 minutes. It is not that easy. And let me help you see why. Here, the 67 miles per hour, let me write this out, miles per hour. And then we are multiplying this by 45 minutes. Everyone, do you see the problem? We're not being consistent here. We see that on one hand, we have miles per hour, and then we have 45 minutes. The time units are not consistent. It is not consistent. And so we have to do something about that. Awesome. And I'll wait for everybody to acknowledge it. Give me a yes or no, yay or nay. I want to make sure that everybody sees them. Sweet. So as long as you see that, everybody, if you notice that, first of all, that's a great job, because you're well on your way to getting the problem right. And if you got it wrong, all that tells me is that you just need to work on converting units just a little bit. That's it. Just got to focus on converting units in the middle of a problem. So Aaron, it's not about converting minutes to hours. It's about converting, or excuse me, yeah, it is going to be about converting the minutes to hours to make it consistent. It's going to be so much harder to turn this into miles per minute. We might as well just turn this into hours. That's it. So here's how we do it. My party people, let me just rewrite the 67, and let me show you what we're about to multiply by. Everybody, when we want to convert minutes to hours, how do we do that? How do we do that? Yeah, Kwaku says we'll divide by 60. Young Carlos says divide. Ramsey says divide. Jennifer says divide. And that is true. We are going to divide, not multiply. Because if you think about it like this, if you had 60 minutes and you want to turn that into hours, well, 60 minutes out of 60 minutes, that equals 1 hour. So we are going to divide, because whenever you're going from a small unit to a big unit, you're grouping up to see how many you can go ahead and fit to make that bigger unit. And that's division. So here, we're going to take the 45 minutes and we'll divide that by 60. And whatever that is now the number of hours that you have. So Aaliyah, the reason that we don't multiply the hour to get minutes is because this is not just hours. This is miles per hour. That's a rate. That's a different unit. You know, you're not just converting the hour. You can't just multiply by 60 to do that. You actually have to consider the miles per hour as a whole, not just the hours. Yeah, so it's a little easier to work with this instead, which, again, it is a little easier because 45 out of 60, everybody, 45 minutes is how much of an hour? What do we know? Yeah, 0.75, but in English, have you ever heard of the phrase 3/4 of an hour? Yeah. We can show that here. You know, we can show that here because we can say, hey, I can divide the top and the bottom here by 15. I can simplify this because 45 divided by 15 is 3, 60 divided by 15 is 4, and so you have 3/4 of an hour. And so boom, we have what we need to make this a little easier. 67 multiplied by 3/4 of an hour. Now we can do this because it's 67 miles per hour multiplied by 3/4 of an hour. And now we're good to go. Before I continue, are we good? Do we understand that we had to convert before we multiply? All right, let's get the job done now, everybody. Let's get the job done. So the way that we can do this is whenever we multiply a fraction by a regular number, remember that any regular number is the same thing as saying that number over 1. So essentially we have 67 over 1 times 3 over 4. And remember that when we're multiplying fractions, we just multiply the tops, multiply the bottoms, and let's get it done. And that's right, Colin, 0.75 is the exact same as 3 over 4. Same thing. So here we have it. We have 67 multiplied by 3. 7 times 3 is 21. 6 times 3 is 18. Carry the 2 is 20. So here we have 201 up top. And then on the bottom, 1 times 4 is going to be 4. And now what we're going to do is divide 201 by 4. So 4 goes into 201. 4 goes into 20. That's going to be 5 times. Drop the 1. And so 4 doesn't go into 1. So we're going to drop that decimal. And then 4 goes into 10. That'll be twice. And if we're rounding this to the nearest mile, everybody, is this going to go up to 6? Or is this going to stay at 5? Yeah, that's going to stay at 5. So boom, that's going to be approximately 5 miles. And there we are. And that's how our answer is, or excuse me, 50. I got ahead of myself. I knew there was something wrong. I'm like, what am I feel good. I feel bad. What am I doing? But then I just kept going. So excuse that, everybody. So right here, I left out one minor detail. So excuse that. So when we did the 4 goes into 25 times, subtract the 20, we get 0. We drop the 1. We drop the 1. And we ask, how many times does 4 go into 1? It doesn't. That's going to be 0. And that's why we drop that extra 0 here. And then we have 4 goes into 10. That's going to be twice, just like we saw. And so that stays down at 50 miles. And so with that, again, the answer is going to be A. And very briefly, before I continue, I want to show you the other way, because remember, 3/4 is the same as 0.75. So the other way that you could have done this, everybody, is 67 multiplied by 0.75. I guarantee you this would get you the same exact answer. We do this over here, 67 multiplied by 0.75, and watch. We have 7 multiplied by 5, that's 35. 6 times 5 is 30, carry the 3 is 33. Then we go to the next line, 7 times 7 is 49. And then we have 6 times 7, that's 42. Carry the 4 is 46. We add these together and we get 5. 3 plus 9, that's going to be 12. Then you have 1, 3, and 6. That's going to make 10. And then you have right there, that'll be 5. So we have 5, 0, 2, 5. And from here, we notice that we have 2 decimal places. So we put 2 decimal places here, and we still get it 50.25, which is rounded down to 50. Either way, it will work. My party people, does that give you a little more assurance that that would work? Sweet. And yeah, and you can still do 45 divided by 60 long division. You would get 0.75. You would. You would. So for anybody here who's still showing any sort of confusion, I want to reassure you by saying this. This is a regular distance rate time question. This is a regular distance rate time question. The only difference is that you have to convert the unit before you actually calculate. That's it. All you have to do was convert the unit before you calculated. And if that was confusing, then it shows me that you definitely want to work on your ability to convert units. Right there. My party people, let me know if that makes sense. Yeah, Manny, that would still work. Yep. Because when you're multiplying by 3/4, you're essentially saying multiply by 3 and divide by 4. And in this specific case, you could have done either one in any order. All right, right on, right on. Let's go ahead and get this party continuing to the next one here. Yeah, we definitely got to work on those conversions for sure. So here we go. Let's look at this next one. So how far did he run? Okay. How far did he run? Everybody, what are we looking for when we say that? Yeah, we're looking for distance. How far did he run? And I'm going to actually edit this one to say in feet. We're looking for how far we ran in feet, but otherwise, that shouldn't distract us too much. We're looking for the distance that was run. Okay. So what do we see? Well, we see that we have a running speed of 15 feet per second. So that's a rate. And then we also see over here that we have ourselves a running time of 3 minutes and 25 seconds. And there we go. So my party people, what's the problem with this one? What do we see as an issue? That's right, Jennifer. We have to convert. We have to convert because notice that when we try to find the distance here, it's going to be the rate times time, but you can't do 15 feet per second multiplied by minutes. That's not going to make sense. That's not going to make sense. We need everything in the same unit for time. My suggestion to everyone is just like in the previous one, we're not going to change the rate. No, 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 no. We are not changing the rate. Give me 1 second, everybody. Looks like my Apple Pencil feels like dying. Give me 1 moment here. Oh man, are you serious? This thing just died. That's funny. Oh, there we go. Cool. So just like in the previous one, we're not going to mess around with this. We're not going to mess around with the miles per hour. We're just going to change the time unit. We change the minutes to hours to be consistent. Same thing over here. We're not going to change this. We're not changing that. We're just going to make sure that all of this gets turned into just seconds. My party people, does that make sense? If we want to be consistent, we see that we want to just kind of adhere to what the rate is telling us. Feet per second, that means that the distance is going to be in feet and the time is going to be in seconds. So that's exactly what I'm saying, Shaletta. Yep, that's exactly what I'm saying. I'm saying that you want to convert to the units of the rate. The distance is going to be in feet and the time in seconds. That's what we want to do. Here, since it's minutes and seconds, we just want it in seconds. So everyone, for every minute, what do we multiply by? Yep, we're going to multiply by 60. Every minute is 60 seconds. So 1 minute, that's 60. 2 minutes, that's 60 times 2, 120. 3 minutes, that's 60 times 3, and that's 180 seconds. We still have the extra 26 seconds. So when we bring this together, we're going to add that back in. And we have ourselves a total time of 206 seconds. 25, not 26. Oh, thank you for that. Sorry. Yeah, I am getting a little tired here. Sorry about that. That is not supposed to be showing as easily as it does. Should have drank coffee before class. Appreciate that. Thanks for finding those mistakes. So here, that's just going to change by one number. That's going to be 205 seconds. I appreciate you pointing that out. But there we are. We have the total time. So now we can apply ourselves. We can do distance equals rate times time. And we're good. That's going to be 15 feet per second times 205 seconds. And then we are done. Before I actually go through the calculation, everybody, does that make sense? We had to convert before we could apply the formula. We just had to make sure that those units were consistent. Excellent. Excellent, excellent, excellent. So let's go ahead and take this and move this off to the side so we can perform our calculation. So 205 times 15. Here we go. So 205 multiplied by 15, 5 times 5, that's 25. Then we have 0 times 5 is 0 plus 2. 2 times 5 is 10. Next line for that one right over here. 5 times 1, 0 times 1, and 2 times 1. Add that all together, and we get right over there. Let me fix that up. And boom, 3,075 feet. And there we go. That's our distance, and we're done. As long as we converted correctly, the rest, super quick, super straightforward. I see that someone's mind got blown. Aaron, how are we feeling? How are we feeling, everybody? Do we feel like this problem is a little more doable now than it was before? Yeah, and if you're feeling rather annoyed by the unit conversions, then I totally recommend, going into unit 3 of your arithmetic reasoning course. If we're talking ASVAB here, that's going to be unit 3 of arithmetic reasoning. It's going to be plenty of practice with unit conversions. Plenty. And remember, if you feel like you've been lost throughout the majority of class as well, again, consider where you are in the program. Have you gone through the math basics completely? If not, then that's going to reveal where we need to give our attention for sure. So let's go into this last one here. This one's probably the toughest one. This one's going to be the toughest one, but let's go ahead and get it done. So here we are. What we're asking in this question is, what is his running speed in feet per second? So right there, we're looking for the running speed in feet per second. My party people, quick question. What's the other word that is the same as speed? Yeah, that's rate. Yeah, if we're asking for the speed, we're asking for the rate. This is the same thing here. So we are looking for the rate. All right. So everyone, when you take a look at the formula, distance equals rate times time. If I'm trying to get the rate by itself, what do I need to do with the time? If I'm trying to get the rate by itself, what do I do with the time? Yeah, we're going to divide. Exactly. Exactly. To get the rate by itself, we have to divide the time from both sides. So just keep that in mind, everybody. Keep that in mind. Because when we plug in the distance and we plug in the time, after we're done with that, then we know that we have to divide to get the final answer. But it's not always going to be as simple as doing it because you have to consider what other details are happening. So here, Donald ran 1,458 feet. So that's definitely a distance. And we see that this happened. Let me get a different color here. And this happened. Let's grab red. That's fine. So this happened over 2 minutes and 42 seconds. And that's going to go right there. Everyone, because we're looking for our answer in feet per second, the time that we put in has to be what unit? That's right. It has to be in seconds. If we're looking for the rate as feet per second, the formula needs to be consistent. Feet per second means the distance is in feet, the time is in seconds. That's all that tells you. That's all that means. So let's go ahead and close this out. So my distance, we know that, 1458. The rate is what we're looking for. And then the time, let's convert it. So let's convert 2 minutes and 42 seconds to just seconds. My party people, what do you do to the 2 minutes to turn that into just seconds? Yeah, Tyler, I heard you. I got you. Yeah, so that's going to be 60 times 2 for sure. So we're going to multiply by 60 seconds per minute. So it's 60 seconds in every minute. So we multiply that, and that's going to give us 120 seconds. And then we still have the 42 seconds here. So we add that all together, everybody, and what do we get total? That's right. The number of seconds is going to equal 162 seconds. My party people, are we understanding how we converted the 2 minutes and 42 seconds to just seconds? Are we comfortable with that? Excellent. So now that we're here, my party people, what we're going to do is we're going to now take that 162 seconds, plug it right in. So this is going to be 1,458 equals 162R. Okay. So now that we're here, we have to figure out, like we just said, right when we started, to get the rate by itself, we have to divide the time on both sides. And that's exactly what we'll do. 162 on both sides. And now we have to cancel that out on the right and then do some long division. So I'm going to do 162 going into 1,458. So now that we're here, here's the problem, everybody. The problem is that I ask myself, 162 goes into 1, it doesn't. 162 goes into 4, it doesn't. 162, or excuse me, 14, it doesn't. 162 goes into 145, it doesn't. And so you're left with having to guess and check. You're left having to guess and check because 162 doesn't go into 145. So now you have to guess at the whole thing. My party people, does that make sense? Like, we're pretty much just going to go trial and error here. That's really much what that is. We're going to go trial and error. So I'm going to go over here and I'm going to say, let's just try 8. So let's see, 162 times 8, 8 times 2 is 16. 6 times 8 is 48, plus the 1 is 49. 1 times 8 is 8. Carry the 4 is 12. Nope, not quite right. That's not quite close enough. So let's go ahead and try another set. Let's try 9. So we'll do 162 times 9. 2 times 9 is 18. Oh, 1 times 6, or excuse me, 6 times 9, that's going to go ahead and be 54. Carry the 1, that's 55. Oh, look at that. And then 1 times 9 is 9. Carry the 5 is 14. Look at that. The answer here is 9. And so we had to guess and check. Wasn't clean, wasn't easy, but we did it and we got it done. And there's the answer, D, 9 feet per second. That's how quickly Ronald was running. How do we feel, everybody? How do we feel? And give me details, not just good or bad, but do you feel like we've gotten better at something, gotten a little more insight or confidence into something? Three for three, let's go. Feeling better, Mike? Feeling better about what? What specifically are we able to say, yeah, I can definitely see myself, getting this part right. Philly, you set it up correctly, right on. So Philly, you've already mentioned to me, yeah, those conversions are a little bit of an issue. Yeah, I got you. I'm glad you're able to understand now. Definitely need more work, Alexandra. Hey, that's what we're here to do. We got this. So my party people, here's what I want to do. So we have about 15 minutes left of class. If we go back to back to back to back, we should be able to get at least 4 questions in. Would you guys like to go ahead and go 4 questions? I'll just highlight the answer and move right along and try these out. And yeah, Frank, we do have plenty of conversion work in the course. Again, in your arithmetic reasoning course, it's going to be Unit 3, unit conversions. It'll be right in there. All right, sounds good. Let's go and have some fun, everybody. Let's go and recap class off the right way. And again, tomorrow, I'm going to be adding all of the questions, the brand new ones that you've seen today. I'll also add those into the distance, rate, time unit. Okay, I'll also add those in tomorrow morning along with the recording of today's class. So here we go. We're going to go ahead and do 4 questions back to back here. 3, 2, 1. Let's have some fun. And that is time, my math party people. That is time. So the final answer here is going to be 404. What you're doing here is subtracting the distances to get the difference. And so there it is. Find the distance for one, the distance for the other, subtract, and you are good. Let's go ahead and dive straight into the next one, my party people. 3, 2, 1. Let's go. All right, my party people, time is up. Go ahead, put those answers in. Put those answers in. I see that a couple of us are a little thrown off because we haven't seen this exact one in today's class yet. We saw it in yesterday's class twice, but I'm going to go ahead and give you the explanation, not the full explanation. I'm going to give you the kind of short version of it. When we're trying to see how long it'll take for the second car to catch up to the first, you need to understand, again, we're looking for time, how long. So we want the catch up time. So we need the distance that we need to catch up. And we need the rate that we are going to catch up at. Again, it's all about being consistent. It's all about being consistent. So since we're trying to find the catch up time, we need the catch up distance and the catch up rate. What's the catch up distance? Well, that's going to be the head start that the car got. So it travels at 75 miles per hour, and the other car didn't start until 5 hours later. So that tells me that the distance that we're trying to catch up at is the head start that the car got. And that is going to be 75 times 5, or otherwise 375 miles. That's the head start that the first car got. And so That's the distance that we need to catch up at. Now, what's the rate that we're catching up at? That's when we're going to take a look at the rate of the first car. And for us to be able to catch up, the second car has to be going faster, right? If the second car is going slower, there's no way you could catch up. So we know that the first car is going 75. Second car, once it leaves, it's going 95. So everyone, since they're going in the same direction, trying to catch up, and the cars are moving at the same time at this point, what's exactly we got to subtract? Because the cars are now moving at the same time over the same period until we catch up. Now we can subtract and we can say 95 miles per hour. Let me actually change that color there. 95 miles per hour minus 75 miles per hour. The difference is the speed at which we're catching up. And so that's going to be 20 miles per hour. That is the catch up rate. So to find the catch up time, we're going to put the catch up distance. And that's going to equal the catch up rate times the time it takes to catch up. So that'll be 375 equals 20 multiplied by t. And so what we'll need to do is divide both sides by 20, and we are done. When we do that, what we will get will be, I believe that's going to be 37.5 divided by 2. So then that'll end up being 18.75. And when we round that to the answers here, that'll be approximately 18.8. And that'll be 18.8 hours of catching up. And that is A. Booyah! Let's go, man. So who here was confused at first, but after seeing the explanation, you're like, oh, super straightforward. And that's the thing, everybody. So anytime that you see a brand new question to you, handle it the same exact way. Not the process, not the, oh, I'm going to take this and do that. No. Handle it the same way in terms of basic strategy. What do you want? What do you have? What's the connection? Once we identify that it's a distance, rate, time problem, we're saying, okay, we're trying to find the time it takes to catch up. Then you know that the distance you're plugging in is the distance that you're catching up, and the rate is your catch up rate. So you have to be consistent in setting up the formula. That's the only way that we're going to have the opportunity to really tackle a brand new question with confidence. Only way. So my party people, that's the last one I got for you because I had to stop and, explain this one, which is a good thing because we were able to understand an otherwise difficult question. But I want to ask you guys about your opinion here. How are you feeling from yesterday's class, from the beginning of yesterday's class to the end of today's class? How much better do you feel? And Greg, absolutely, this class will be, the recording will be available. I'll be putting it up tomorrow before noon. I figured out a solution to make sure I can record and stream at the same time. So we're good. And this is great. Looks like you guys are all feeling much better than you have before. That's solid. I love it. I love it. I love it. I love it. So I got you, Nathaniel. So yeah, make sure to watch that recording because that way you'll be able to rewatch everything we've done and get a second look and a second try at everything here. So if you feel like you need more work, that's cool because the proper practice that we're going to get, it's always going to lead to a better base, a better foundation, and that's always going to lead to that higher score that you're looking for. So my party people, with that said, the next math class that we have to look forward to is going to be on Monday. And if you would like, yeah, I am absolutely down to do percentages for percentage word problems on Monday. Would you guys like to do that? Right on. Yeah, we'll do that. Let me mark that down in my notebook. We will do percentages on Monday, and I'll go ahead and create at least 5 new types of questions here. That way we can really dominate this. So let me just skip this on over. There we go. So my party people, with that said, you guys have been absolutely amazing. Let me just write down that we're doing percents on Monday so I can create brand new questions on top of what we already have. But don't forget, everyone, in the program, you have everything you need to continue learning between now and next Monday. We have our paragraph comprehension class with Coach Sheena tomorrow. So for English, get ready to continue learning. And before we go, I want to make sure that you guys understand how special what we're doing is. There's not many places that you can go to where you can sit in a lecture where you're in a group setting and you can still take away as much as you possibly could. So I want to thank you, every single one of you guys, for being respectful in these classes, for showing up, putting in your best effort. That's what this is all about, because everything that you ever want to earn in life, it comes from the effort that you give and the patience throughout the entire struggle. So you guys are on the way to what you want. Continue moving in the right direction. And I just have to thank you guys for doing things the right way. You guys are amazing. So with that said, everybody, if you have any questions at all, as always, feel free to email us at the support line. And good news, I finally was able to hire permanent help in terms of responding to communications and overall having an assistant to help me out. That way, whenever I am not doing well medically, there's still always going to be someone there to reply to every single one of your questions. So we're really happy that you guys are going to continue getting the support that you need. And on top of that, I always ask that, if you feel like supporting us in any way, shape, or form, please make sure to shout us out on TikTok, on YouTube, on Instagram, on Facebook, wherever you guys are, to your recruiter as well. Spreading the word through word of mouth has been the number one way that we've been able to continue succeeding doing what we do. So as always, everybody, thank you guys for putting in the time and the effort. I'm excited to see you guys with Coach Sheena in tomorrow's class. And then again with me coming up on Monday for April Fools. Yes, we do still have class, but I'm really excited. So thank you, everybody. You guys are amazing. Have a great weekend. I'll be medically unavailable on Thursday and Friday because of my procedures, but I should be good to go on Monday. Worst case scenario, if I'm not feeling good, I'll cancel. But I feel like after almost a year doing these infusions, I'm feeling pretty good about my ability to recover faster. So you guys are awesome. Have a great night. See you tomorrow's class, and then see you Monday. Let's ace the ASVAB. Cheers.